Alright, guys, so we're going to go over the lesson we did today and just giving you a chance to have recorded notes. So today we were talking about expected value. And today we're talking about expected value. Today's date is the 20th of April. Alright, just remind you we're in math 102. Alright, and so we're talking about expected value. So, before we talk about expected value, there's something we should discuss, which is, or just mention at least, is this idea of what is a random variable. What is a random variable? And my best definition I can come up with now, I can summarize what I've read or learned, is that a random variable is some quantity, of interest, used some quantity of interest used to denote some outcome in a sample space. Okay, so that is the idea behind a random variable. Alright. So let's get straight now to the definition of expected value. Alright. So let's get straight now to the definition of expected value. So the expected value for random variable. Let's just note here that big X is a random variable. Alright, we're going to be talking about X as a random variable. So here's a good example. Toss a coin, or toss three fair coins. Alright, so toss three fair coins. Alright, and what we would get here, if we look at the sample space, what we would get, just look at the sample space here. So you can get H, heads on the first, heads on the second, heads on the third. You can get heads on the first, heads on the second, tails on the third. You can get heads on the first. Let's do the two H's. Tails on the second and heads on the third. Or you can get heads right on the first and tail on the second and tail on the third. Alright, now let's just, for ease for me, let's just go to all tails. Tails on the first, tails on the second, tails on the third. And do a similar construction here. Tails on the first, tails on the second, and heads on the third. And tails on the first, heads on the second, and tails on the third. And now we got tails on the first, heads on the second, and heads on the third. Alright, so there goes our sample space. And so we can assign a random variable here. We can assign a random variable can assign x to be 0 heads, which would be this outcome right here, right? So this would be this outcome right here, 0 heads. All right. You can assign x to be 1 head, and then that would be this outcome right here. That's 1 head. All right. Is there another one? Okay. And this outcome right there has 1 head also. All right, and so does this outcome. All right, so let's just give this a little extra marking. All right, is there another outcome with 1 head? No. Now we can assign again some random variable x equals 2, which would be 2 heads, right? Which would be let's use a different. Let me get a highlighter here. All right, so we're looking at 2 heads, so that would be this, right? It would be this here, 2 h's, and that would be this right here. All right, and we can finally assign x as a random variable here. X equals 3. We can talk about having getting 3 h's here, 3 heads, which would just be this one right here, and would just be this one right here. All right, 3 heads. All right, and so that's the whole idea behind a random variable, right? So now let's just get to the official definition of expected value of a random variable. All right. So the expected value of a random variable, the expected value of a random variable here is just what we call e of x. In this particular case, we're thinking of a situation similar to when we had relative frequency. So it's kind of a similar idea. We do similar kind of an up layout here. So the expected value here is just going to be the expected value itself. I mean the random variable itself, right? Times it's going to be the sum from I equals 1 to n of the random variable. I'm going to use capital N. Random variable x of I and its respective probability p sub I. Alright, and they're taking the sum of all of these. So basically what it's saying is it's just x1 p1 plus x2 p2 plus and so on plus x and pn. So it's when we have these n we have this random variable taking on these n different values here, and then we have the n probabilities associated with them, and so the product of each value with this probability added together is what gives us the expected value. That's what it is here, right? So let's look at an example. So let's look at the example a while ago where we tossed 3 fair die, right? 3 fair dice. Okay, so we're talking about example here. Let's go an example. So example, we toss 3 fair, toss 3 fair dice, and so if we can put these in let's just put these in a table here, right? So x is our x equal x sub I, that's our random variable column, and then this is going to be for probability. So p usually write a big X and a little x sub I, right? And then here we're going to look at the product of all these. I'm going to call these basically your p sub i's, right? Just call them your p sub i's. Okay. And so what we're looking for now on the right column, again, this here, we're calling this our p sub I. We're calling this, this is not a quotient. We're saying this here, we're going to call our p sub i's, right? So what we want in the right column is going to be x sub I times p sub I, little p. Okay, it's the big P here, it's just little p. Alright, and so what we have here, when the random variable is 0, x equals 0, and the probability of having 0 heads we found out before, that was, probability of getting 0 heads was, I'm going to call that p sub 1. So we're going to call this x, we're going to call this x sub 1, right? Alright, so x sub 1 is 0 here. Alright, and so p sub 1 is going to be 1/8. Alright, p sub 1 is 1/8. And here we have x sub 2, 1, and p sub 2 here. Again, this is the probability of having 1h, and we found out that was going to be, let's see what that was. Let's get back to our notes. Probability of having 1h, that was probability of having 1/8 was 1, 2, 3, 3 out of 8. Probability of having 2 h's, p2, it was also 3 out of 8. The probability of having 3 h's was, sorry, this was supposed to be a 3, was equal to 1 out of 8. Alright, and so what happens now is we multiply these. So we get 0 times 1/8 is just 0. 1 times 3/8 is just equal to 3/8. 2 times 3/8 is just going to be 6/8. And 2 times 3/8 is 6/8, and 3 times 1/8 is again 3 times 1/8 is 3/8. Alright, and so when we add these up, what we get is 12/8, which is going to be 1.5. Alright, so what we're saying here is the expected value when you toss a coin is on average you should get 1.5. You get 1.5 heads when you toss 3 fair dice. Actually, 3 fair dice, you should get 1.5 heads. Alright. Okay, so that's what should happen here. Alright. So expected value has different uses. Alright, so there are different ways of looking at expected values, and we're going to look at a few examples. Dealing with expected values. Alright. Okay, so here's an example which I want to show you and want to discuss. Look at this particular case. class of 120 students are driven 3 buses to a symphonic performance. Alright? There are 36 students in one of the buses. Alright, there are 36 students in one of the buses. Camera, okay, good. There are 36 students in one of the buses, and 40 in another, and 44 in a third bus. When the buses arrive, one of the 120 students is randomly chosen. Let X denote the number of students on the bus that randomly chosen. Let X denote the number of students on the bus of that randomly chosen students and find E of X, alright? So we're trying to see the number of students on the bus if you pick a randomly chosen student. Alright? So that's the question we're looking at now. Alright, so here, again, we have 3 buses. So this example we're looking at, so we got 3 buses. We got bus 1 has 36 students. So bus 1, we got 36 students. Okay, bus 2 has 40 students. And bus 3 have the other 44 students on the trip. So there are 120 students on a trip, right? 120 students on the trip. And they're going in 3 buses. And that's the situation here. And so we are trying to figure out what is the expected value that the expected number of students on a bus that you, if you pick a student from that bus, from any random student from a bus, what is the expected value? What is the expected number of students that's going to be in that bus, right? Okay, so it's a situation here. So what we have here, we want to go back to a random variable situation. If you pick the probability that the random variable here being number of students in a bus, probability that a student will be in a bus with 36 students is going to be 36 over 120. Number of students, number of buses, number of students on that particular bus with 36 students, obviously 36 students on a bus, 36 of the 120 students on a bus. The other one is going to be, you can also think about picking a student from the bus with 40 students. What's the probability of that? Well, there are 40 students out of 120. Alright, and then now you think about picking from the bus with 44. 44 out of 120. Alright, and so the question is, let's try to work out the expected value here, right? So again, these are random variables. Our random variables here, random variable here is x. The value of these, the random variable in this first case is 36, then in this case is 40, then in this case is 44, right? Alright, and so now we're going to basically try to look on calculating the expected value that if you pick a student at random, how many students are going to be in the bus that the student is coming from. Alright, so what that's going to be, same formula again, you're going to have here the expected value here is going to be x sub I times p, x sub 1, so make it simpler, x sub 1 times p sub 1, it's x sub 2 times p sub 2 plus x sub 3 times p sub 3, and so on. This time you're stopping at x sub 3, there are only 3 buses. So picking a student from the bus with 36 students, 36, here the probability is associated with that is 36 over 120. obviously 40 times 40 over 120 plus 44 over times 44 over 120. Okay, and so if you do that, you can do some simplification if you want. If you wanted to, you could simplify. 12 into 36 goes 3 times. That use a different color. Okay. 12 into 36 goes 3 times. 12 into 120 goes 10 times. 40 into 120 goes 3 times. 4 into this goes 11. 4 into this goes 30. Alright, and so you can do some calculation on this. And when you do this, what you're gonna get is gonna be, I can have a least common denominator of LCM of what now? I shouldn't have done that. LCM of 30. So I shouldn't have done this. I really should have tried to divide by 4. Okay, so I should have divided by 4 and get 30. Divided by 4 here and get 9. Okay, good. And I should have divided by 4 and get 30. By 4 and get 10. I should have divided by 4. Okay, good. Awesome. So what I have now is going to be my answer that I'm looking for. Alright. Okay, so 36 times 9 equals 324 over 30 plus 40 times 10, 400 over 30 plus 11 times 44, 484 over 30, and if you add all that up, what you're going to get is 1208 over 30, alright, which is 1208 over 30, which is approximately 40.27. So what we're saying here is that the expected value here it is not the same as the average, right? It's not the same as just the average number of students. This is basically just pick a student at random and the expected seating capacity of the bus they're taking, or how many students are on that bus rather. The expected number of students is just going to be 40.27, okay? So